let's do a little nitration. Mac. He kind of likes this Mac. Big fan. But yeah, let's just go over let's just look at the reaction. All right, that's our reaction there. Basic structure of this reaction. You have your HNO3, nitric acid, I believe, and then you have your sulfuric acid. So you can put your NO2 on. The problem with this Mac is that there's so many structures you need to know. First of all, you need to know the structure of this in order to get 100% on the Mac. You need to know nitric acid structure, that's nitric acid. Or I don't want to write that. I want to write HNO3 because really you don't need to know nitric acid's the name. NO2, what that actually is, it's a nitro group, but what it really is, that's what it looks like every time. That's the N. Then you have O1 and O2. You have two O's and an N, NO2. Obviously, you don't see any charges in this thing, but there are charges there. You've got the positive and you got the negative. And you really need to know this structure because it's a big part of this Mac. And finally, sulfuric acid, that's this. That's pretty simple to remember, but this one gives me a lot of trouble. So you want to just take some time before the exam to just memorize that. And then we can finally get started on this Mac. So let's look at the beginning again after we went over. So that's our basic structure. Like I said, I recommend just drawing it like this all the time because it's more explicit and you know what you're doing. But you don't have to. So let's start. So my recommendation for this Mac is just to, honestly, this one, to me, like the Friedel-Crafts and the bromination, those all make a lot of sense to me. To me, this one doesn't really make as much sense, so I just memorized it. But really, you can just memorize it in like an hour. Anyway, so the first step here is you're not even getting the pi attack involved yet. You got to make your electrophile first. So actually what happens is the O from this OH goes and grabs a hydrogen from there and pulls that. So then you end up getting, all right, well now when you kind of do the Mac, it kind of starts to make sense, I guess. So obviously, when you pull a proton off of the sulfuric acid, you get this thing. And then when this thing grabs a proton, you get this. And now I remember why this is making sense. Because you have water as a leaving group. So it just bounces. It's like, I'm out of there. That's what it says. So one way you can do this, you can actually show it leaving and then explicitly show, honestly what you can do is you can show that leaving. So then you actually have two positive charges on there, all right? But you've got some lone pairs here. Because it left two positive charges. This is kind of going into some minute details. Anyway, I think that can go down there. You get a res form that's really looks weird, okay? So you've still got two positives and a negative, two positives and a negative, right? However, you can show these extra resonance forms if you want to. In this case, when I took the class, he just showed the water leaving and then this O coming down. So you can go right to this, which is your electrophile. You can also access this structure by doing this, remembering your lone pairs, doing that. If it helps you to draw on the lone pairs, please do. No harm in doing that. So this was really explicit, but I do believe that you can just show that leaving and then that popping over there to give you this thing. However, this is extremely detailed, which he did show in class, but not sure if it's going to be necessary, but if you have to, if you can remember to do so, I would show all that because it never hurts to show a resonance form. And most of the time, almost every single time, you need to show every possible res form. Anyway, moving forward, we have our electrophile. Remember that structure, we're going on the back. Moving forward, so that's our electrophile that we made. No idea what the name of that is, but it has a name. Now it's time for the pi attack, right? So now you can't have 5 bonds to a nitrogen. I don't think you can. Either way, what happens here is you got a pi attack on that N because it's got a positive charge, electrophilic. Excuse me. then one of these goes up. And now it's starting to look strangely familiar. Let's just say it adds right here. Now it's starting to look strangely familiar. So what happened during this pi attack is the nitro group added here, you got a hydrogen there, and now we have a positive charge there. So what I'm going to do is I'm actually going to show all the res forms, which you would definitely need to do. Dr. MS is a big fan of resonance. Going to want to make sure you get all those res forms. Okay, so just go from one to the other. You can just dance the pi bond around the ring, as he says. He always uses verbs to describe the movement of the electrons of the. I think that's kind of funny. You can dance it around the ring, you can walk it around the ring, or you can run it around the ring, whatever you want to do. Anyway, it's time to deprotonate, I suppose. So let's look at how are we going to deprotonate in order to get our final product. Well, we've got two choices. If you remember, we actually made this thing when we deprotonated from the sulfuric acid. So we've actually got this minus charge, which has, it can act as a base. But then you have to remember about this water that fell off. And actually that can be used too. And I want to use that because it's easier to draw. So that's still in solution. Anything that kind of falls off earlier, such as this and the water, you can still use those later to deprotonate. So like that, and then like that. The bond from the H goes onto there. And then the electrons grab that H. It's not the H grabbing the O. That makes absolutely no sense. It's these electrons which are, gonna try to act as a base and, grab a proton. And the bond here from the H to the carbon pops on there. This forms H3O plus when water grabs that proton, but that's not really important. The important thing, I'm going to draw it nice and big because it's so important, is that we reformed our aromaticity and now we have a product. So now that's basically it. And this, obviously, as you know, is the same thing as this. Bam, we're done. That's nitration.